Hi guys, we're back with our second learning target, which is learning target B. I can identify and factor special cases in quadratic expressions. So one great thing about some of the times when we're factoring is if we can identify the expression as a special case, we have patterns that help us factor them more easily. The first special case we have is called a perfect square trinomial. Remember, trinomials have three terms. Okay, so let's see, how do we get a perfect square trinomial? When we square a binomial, we get what is called a perfect square trinomial. So for example, the binomial x plus 4 quantity squared, when we do that, when we square something, that means we multiply it by itself. So I need to multiply x plus 4 times x plus 4. And when I do that, distributing my x times x, I get x squared, x times 4, 4x. Then distributing my 4 times x, I get another 4x. And then 4 times 4, I get a 16. Combining my two like terms in the middle, the 4x, I get 8x. And then my last term is 16. What we have just gotten is a perfect square trinomial, named that way because the first big hint is that your first term and your last term are perfect squares. Remember, perfect squares come about by multiplying something by itself. So what did we multiply by itself to get x squared? Oh, that was x times x, right? That is squaring x, okay? What did we multiply to get 16? That was 4 times 4. That's 4 squared. Okay. So the first big hint is that the first term and the last term are both perfect squares. Then, if that is true, we check that the middle term is actually 2 times the two terms in your binomial. So what's 2 times x times 4? Well, that's the same thing as saying 2 times 4 times x, which is 8x. And sure enough, my middle term is 8x. We'll get more into that in a second. But what I've just showed you is the pattern. The first and last term are perfect squares. So let's look down here at the patterns. So you can either have a squared plus 2ab plus b squared, or you can have a squared minus 2ab plus b squared. So a squared is your first term, b squared is your last term. Those are both perfect squares, okay? They factor into the binomial that's just a plus b quantity squared, or if we have a subtraction sign here, it's a minus b quantity squared. And we just double check that the middle term is 2 times a and b. And remember, a would just be the square root of this first term, b would be the square root of that second term, last term, excuse me. All right, so basically they factor very similar. It's just that if the middle term is positive, it's a plus b. If the middle term is negative, it's a minus b. So let's take a look at the first one. I have x squared minus 10x plus 25. So I say, hey, this is a perfect square. Its square root is x, right? I would square x to get x squared. And this is perfect square. Its square root is 5. It's because 5 squared is 25. And then I have a middle term of negative 10. So that would make me believe that I should write x minus 5 quantity squared. And you can always check your work. I'm going to do that in a different color. If I square this factor x minus 5, that's going to be x squared minus 5x. Bump, bump. Then a negative 5x. Negative 5 times negative 5 is a positive 25. And what do you know? A negative 5x plus a negative 5x does give me a negative 10x. So I have correctly factored that perfect square trinomial. Let's look at B. B is, you'd think, oh my gosh, so hard because my A value is 9. And then you'd have to think about all this stuff going on there. But then you think, hey, 9, that's a perfect square. And then I look at my C, and that's also a perfect square. What's the square root of 9x squared? That would be 3x, right? If I multiply 3x by itself, I get 9x squared. What's the square root of 25? Oh, 5. And then I look in the middle. This is a negative. So my factor that I'm going to square, my binomial, will be 3x minus 5 in parentheses squared. Okay, let's go C and D. C, I look at my first term, sure enough, that's a perfect square. My last term, 1, that's a perfect square. What's the square root of 4x squared? 2x, right? If I square that, I'll get 4x squared. And what's the square root of 1? 1. Okay, so my factor would be 2x, and then I look at the middle term, it's positive, plus 1, quantity squared. And finally, my last one, Ooh, guess what? We're going to keep the last one for tomorrow because we're going to have to do some GCF work, which we didn't do in the first video. We'll do it tomorrow in class. We have to move to our next special case, which is a difference of squares binomial. When we multiply opposite binomials, we end up with a difference of squares binomial. You're like, what's that? I'll show you. Opposite binomials would be like x plus 4 times x minus 4. So when we multiply those, let's distribute. We get x squared minus 4x. Then we go plus 4x, and then 4 times -4 is minus 16. And what happens here, these middle terms are opposites of one another, and they cancel out, so I'm left with x squared minus 16. This is called a difference of squares binomial because it's a difference. We're subtracting two perfect squares. Also, you don't have your middle term of x. The reason is that this actually is, and we would never write this, but it's really x squared plus 0x minus 16, right? We're not going to write 0x, but that's why it's just a binomial, okay? Our x term has fallen out. When this happens, we look at our pattern down here. If we have a perfect square, let's say a squared, minus another perfect square, b squared, it factors to the two factors that are opposites of one another, the square root of a squared, which is a, plus the square root of b squared, which is b, times a minus b. Just like, let's look up here, x squared minus 16 factors to x plus 4 times x minus 4. All right, so letter A, x squared minus 9. Oh, x squared is a perfect square, 9 is a perfect square. We're subtracting. This is the difference of squares. So what's the square root of x squared? X. What's the square root of 9? 3. So that factors into x plus 3 times x minus 3. Okay, let's look at B. I have 9x squared minus 25. What do you know? 9x squared is a perfect square. 25 is a perfect square. I'm subtracting. This is a difference of squares. Square root of 9x squared is 3x. The square root of 25 is 5. So my opposite factors would be 3x plus 5 times 3x minus 5. And we're going to end with example C. We're going to do D in class. All right. C, perfect square, 9x squared. Whoa. And D, and 1 is a perfect square. The square root of 9x squared is 3x. The square root of 1 is 1. So 3x plus 1 times 3x minus 1. All right, guys, I hope you're excited to have more fun with factoring tomorrow. See ya.